If you are about to study calculus, or if you already took it and felt like you didn't really understand anything, this video is important. Because calculus usually becomes difficult long before the difficult topics even start. In this video, I'm going to explain what calculus really is and what you need to understand before studying it, something that is almost never said explicitly. Don't worry, this won't be very technical, and you won't see formulas or exercises. Most students start calculus with the wrong idea from day one. They think calculus is a course full of hard mathematics, long formulas, rules to memorize, and mechanical exercises. And when they start seeing limits, derivatives, or integrals, it feels like they're just learning meaningless symbols. The problem is that calculus does not start where people usually think it starts. Calculus is simply a language to describe how things change, even when that change is very small or happens continuously. When you study velocity in physics, what matters is not only where an object is, but how its position changes over time. When you study costs in economics, what matters is not only the total cost, but how the cost changes when you produce one more unit. When you analyze a system in engineering, what matters is not only the final state, but how the system evolves. Calculus exists to answer these kinds of questions. The formulas come later, as tools, not as the core of the course. If you start calculus thinking that the goal is to memorize rules, the course becomes confusing from the very first week. Before talking about limits, derivatives, or integrals, there is something you need to understand conceptually: functions. To talk about change, you first need something that can change. And no, a function is not just an expression with an x and a y. A function is a relationship between two quantities, where the value of one depends on the other. For example, if you say that the distance traveled depends on time, you are describing a function, even if you don't write any formula. If you say that the total price depends on how many products you buy, that is also a function. The common mistake is believing that understanding functions means knowing how to manipulate formulas. In reality, understanding functions means being able to answer questions like, what happens to one quantity when the other increases? Does it grow fast or slowly? Does it always grow, or only in certain intervals? Calculus is built on top of these questions. If you don't understand this, the course feels like moving forward blindly. Now, something that appears very early in calculus: limits. Many students see limits as a strange mathematical formality, but the idea is simple. A limit is a way of asking what value a quantity approaches when another quantity gets closer to a certain point. It's not about reaching that point exactly, but about observing the behavior around it. It's a way to study situations where change is so small that it cannot be measured all at once. For example, when you ask what happens to velocity as time approaches zero, you are thinking about a limit, even if you don't realize it. Limits exist because change does not happen suddenly. It happens gradually. They don't exist to complicate your life. They exist because the real world does not change in discrete jumps, but in a continuous way. Next come derivatives. A derivative is not a rule or a mechanical procedure. A derivative is a measure of the rate of change. If you have a function that describes position as a function of time, its derivative tells you how fast that position is changing, which is velocity. If you have a function that describes velocity, its derivative tells you how velocity changes, which is acceleration. That is what a derivative is: a precise way to quantify change. The formulas you see in class are not the concept. They are just shortcuts to compute change quickly when the function has a certain form. If you don't understand this idea, the rules seem arbitrary, when in reality, they do make sense. The most common mistake before and during calculus is studying it like algebra, memorizing procedures and repeating them without understanding what they represent. That can work in the short term, but it fails when problems change slightly, when new situations appear, or when you have to apply what you learned in physics, chemistry, or engineering courses. Calculus is not learned by memorization. It is learned by building intuition first and technique later. Before studying calculus, you should be clear about these ideas. A function represents a relationship between quantities. Change is the central concept of the course. Limits describe behavior, not just numbers. Derivatives measure how something changes, not just how to compute it. If you understand this, the course completely changes its character. Calculus is not easy or hard by nature. It becomes hard when it is taught starting from the wrong place. On this channel, I'm going to start a series explaining calculus from scratch, calmly, with intuition, and without assuming you already understand things that were never explained properly. If this approach helps you, I invite you to watch the next videos and subscribe, because besides calculus, I'll also explain other courses you'll see during your university years.